Hello everyone and welcome to edupediaworld.com, your destination for online education. Friends, today in chemistry we are going to start with the mole concept. Now, what is mole? It is basically unit of numbers. Now take an example like you're going to market to buy eggs, shoes or paddy, a calendar. Now, how will you buy? You'll say to the seller, give me 1 dozen of eggs. You'll say 1 pair of shoes. You'll say a quintal of paddy. You'll say a year of the calendar. Now, these are the units basically, units of number that gives, dozen gives 12 items, that is 12 eggs. It gives 2 shoes. Quintal gives 100 kgs of paddy. A year contains 12 months. Similarly, 1 mole is equal to 6.023 into 10 to the power 23 moles of particles. Now, what is this number? This number we call an Avogadro number. This, for example, the Avogadro number we say is the number of particles. See, this particle can be anything, like which you cannot be, it cannot be seen, or there are so many or trillions and trillions of particles which can you cannot be count manually. These number of particles are present in a mole of any substance. That is equal to 6.023 into 10 to the power 23 particles. This number is called Avogadro number, or you can say constant also. So basically, what is 1 mole? Or you can say a mole. That is, we can say a mole is a group of particles in any substance which is equal to 6.023 into 10 to the power 23 number of particles. That is, 1 mole is 6.023 to 10 to the power 23 number of atoms in any kind of substance, or 1 mole of molecule is called this much of molecules in any substance. That is, the substance having atoms or molecules or ions, anything where 1 mole is equal to 6.23 10 to the power 23 number of particles. Now let's see the proper definition. That is a group of 2.623 into 10 to the power 23 particles. It may be atom, molecules or ions. Anything of a substance is called 1 mole of that substance. That is, 1 mole of atom is this much of atoms. 1 mole of molecules is this much of molecules. Now let's go to the detailings of the mole concept, which gives the proper picture. In terms of chemistry, we also say, like for example, if in chemistry we talk about elements, compounds and mixtures. If this is a balancer, we have here the atomic mass of atoms of an element or any substance, or here is 2.623 into 10 to the power 23, that is 1 mole. 1 mole is also equal to this much, and 1 mole is also equal to this much of atoms, or you can say molecules or any other particles. So if we go deeply into this, we study atomic mass, we study Avogadro numbers, we study atomic mass unit, we study molar mass, we study molecular of any particle. That is, first if we talk about atomic mass is nothing that which is an mass of an element of an one atom. That is, atomic mass of an element is that which contains the mass of one atom of that element. For example, if you see here, we call it atomic mass. That is, it is a mass of an element of one atom of that element. For example, hydrogen have atomic mass of 1.099 grams, right? Now, if we talk about atomic mass unit, it is nothing but 1/12 of the mass of an atom of carbon, carbon 12, that is, it is a unit of mass used to express atomic mass and molecular masses. We have seen here that the atomic mass and the atomic mass unit are totally very interlinked. If you talk about only atomic mass, which is only the mass of one atom of that particular element, and the atomic mass of unit is 1/12 of the mass of an atom of carbon 12. Carbon 12, yes, carbon 12 is an element that has been taken as a standard to calculate the calculations easily, and it is also used as a mass to express the atomic masses and molecular masses. Now if we see, we have mole for atoms and for molecules. Whichever particle is present, it is the particles which is present in that particular element. In substance, you can say, if the substance is having an atom and we are having the numbers of atom in that particular substance, we are knowing the particles. So we have the different formula or different definition all throughout for each and every different particles. That is, if we say 1 mole of atom, or here we say 1 mole of molecule. Now what is 1 mole of atom and what is 1 mole of molecules? We'll quickly go into this particular definitions. That is, 1 mole of atom is an element has a mass equal to the gram atomic mass, right, of that particular atom. That is, for example, we say 1 mole of, say, hydrogen, or say oxygen. These are the elements. If you talk about gram, a 1 mole of atom, that is a gram atomic mass of hydrogen, if we say, is 1 gram. If we say gram atomic mass of oxygen is 16 grams. That is, now if you think about what is gram atomic mass, this is nothing but the numerical formulation of atomic mass, which is just converted into the units. It has been converted into U to the G. Now we talk about the molecular part. It is nothing but 1 mole of, say, uh, O2. This is a molecule, right? So we'll just multiply 1 mole of atomic mass to the molecules. That is, it will be 32 grams. Now we'll quickly see the differences between these two. That is, if we see about the mole of atom, that is a 1 mole of atom of an element has a mass equal to the gram atomic mass of that particular atom. That is, 1 mole is equal to gram atomic mass of that element. And similarly, the mole of molecule, that is the 1 mole of molecule of a substance, has a mass equal to the gram molecular mass of the substance, right? That is 1 mole of mass is equal to gram molecular mass of the substance. What is gram molecular mass? Is nothing but the numerical formation of masses of that particular molecular mass. Now we talk about what is molar mass. Yes, molar mass is nothing but the atomic mass, which is only the numerical value of the atomic mass, which I just said you that it is a gram atomic mass, and the molar mass are equally defined. They're the same thing. That is the unit of U, that is the AMU, will be changes into grams, right? That it will be nothing but the only numerical value of an atomic mass. For example, you can see here element is written, the symbol is written, that the name of the element, and here it's atomic weight, that is the atomic mass, which has been written out in the beneath of every element. That is a gram atomic mass. Now friends, if we see the example problems, or if you want some numerical formulations, let's take an example of these. First, the mole of an atom. That if we talk about the first problem, that is, what is the mass of 3 moles of nitrogen? Before starting to the problems, we should know all the formulas. That is, if we talk about the calculation part of mole of atoms, we should know the formulas equations, you can say. That's first equation we have derived is 1 mole of atom is equal to 6.023 into 10 to the power atoms. Second equation what we derive is 1 mole of atom is equal to gram atomic mass. And the third, which is equal to these two equations. The third equation, if we derive from these two equations, you can see these two equations, which will be 6.023 into 10 to the power 23 is equal to gram atomic mass. Now come back to the problems. The first problem says that what is the mass of 3 moles of nitrogen? Let's calculate. That is, whenever we have given a numerical, we should follow 3 steps. First, we should know what the question says, that we should read the numerical properly. That is, first we should write given substances. What is given to us? Nitrogen, having atomic mass 14. What else is given? That is 1 mole of nitrogen atom is 14 grams. Now what has been asked, that is to find, we have to find 3 moles of nitrogen. Like, what is the mass of the 3 moles of nitrogen? How will you do? Like, what equation you'll be using? You'll be using the multiplication, that is, we will be multiplying 3 moles with atomic mass, that will be giving 42 grams. Now the answer is 42 grams. Now let's come to the second problem. Now what is our second problem is saying that it is a calculate the number of ion weighted 2.8 grams atomic mass of an ion. That is, it is asking what is the number of ion atoms, that is number of atoms. Now let's start with the calculation of next problem, that is like we have done in the first. What has given? We have been given 1 mole of iron is equal to gram atomic mass of iron, that is 56 grams. Now we know that 1 mole of iron element contains 6.023 into 10 to the power 23 atoms. Now we should give into the calculation part, that is 56 grams of contains 6.023 into 10 to the power 23 by the third equation, right, which we have derived. By this we get 1 gram of iron will be dividing 6.023 into 10 to the power 23 by 56. Now 2.8 grams of iron contains 6.023 into 10 to the power 23 by 56 into 2.8. That is a simple calculation we have to do. It will come, the result will come outing be 3.011 into 10 to the power 22 grams. That is 2.8 grams of iron contains 3.011 into 10 to the power 22 atoms. I hope you have understand the calculation part. Now we'll move on to the molecular problem. That is a mole of molecule. We have two problems here, example problems. Now first we know the example problems we have studied. We should know all the 3 or equations which will be calculating this mole of molecules, let's find out what are the actual equations which we have already derived from the theory part. Like mole of atom, we have mole of molecules with much three equations. That is, let's write mole of molecule first so that you will be understand properly. First equation which we have derived from the definition, that is 1 mole of molecule is equal to 6.023 into 10 to the power 23 molecules. Second equation which we have derived is 1 mole of molecule is gram molecular mass. Third, from these two we have derived 6.023 into 10 to the power 23 is equal to gram molecular mass. Now let's calculate the problems. What the problem says is, first problem, how many moles of calcium carbonate are present in 10 grams of substance, right? So let's start with the first problem. First problem is let's find out 1 mole of calcium carbonate is equal to molecular mass of the CaCO3, that is calcium carbonates in grams. Let's calculate first. That is mass of calcium plus mass of carbon plus mass of oxygen into 3. That will come out to be 40 plus 12 plus 16 into 3. That will be coming out as 100 grams. As we know now, 1 mole of molecules of CaCO3 is 100 grams. Now let's check out what 100 grams of CaCO3, that is calcium carbonate, is equal to 1 mole. 1 gram is 1 upon 100 and 10 grams of CaCO3 is 1 by 100 into 10. It is simple calculation that comes out to 0.1 mole. Thus, we say 0.1 mole of calcium carbonate are present in 10 grams of calcium carbonate. Now we should please note that this problem can also be solved directly by giving this formula, that is number of molecules is equal to mass of substance upon gram molecular mass. This will give the result of first problem. Now let's check out the second problem, that is what is the number of water molecules contained in a drop of water weighted 0.06 grams. First, we should check out what is given in the problem, and then we should look for the equations which we can use and take out the results. This is the last problem we have done like this. In the second problem, we know that 1 mole of water is to 6.023 into 10 to the power 23 molecules, that is water molecules. So to calculate 0.06 grams of water, what should we do? Yes, we should first calculate the molecular mass of water. I will calculate. This is the formula, and this is 2 hydrogen plus 16 oxygen, that will be coming out in 18 grams. That is 18 molecular mass of the water. That is gram molecular mass is 18 grams, or we can say 1 mole of water as well. By the second equation which we have already derived. Now putting all the equations or all the numerical into the equations, we get 18 grams of water contains 6.023 into 10 to the power 23 number of water molecules. Now 0.06 water contains, that's a simple calculation, that is a mathematical calculation left behind upon gram atomic, the gram molecular mass into the given weight. The result will be coming out like 2.007 into 10 to the power 21 molecules are present in that water. Now friends, we have discussed many aspects of mole concept. We have also derived many equations. We have also solved 2-3 problems. I hope you have understand the concept of molecule, or you have understand the concept of mole. First, yes, what is point to be noted? First, mole is an unit of numbers. Second, mole is equal to 6.023 into 10 to the power 23. It may be atoms or molecule. What is molar mass? It is numerical value of, or say 2 atomic mass of element or molecular mass the molecule.
1 mole is also equal to gram atomic or molecular mass of the element or any substance. Thank you, friends, for attending this session. Thank you.